to our DRECA conversation this month. My name is Jody Flagg. I am with Alberta Milk, and today we're interviewing Dr. Annie Claessens with Agriculture and Agri-Food Canada. Dr. Claessens, can you give us a brief introduction of yourself and tell us about your background and involvement in dairy?
Hi, Judy. Thanks for having me today. So, yes, I'm a forage and biomass breeder. So I've been working since 2011 at the Quebec Research and Development Center. So I've been a part of the team, the breeding program team. So I work with 3 other scientists, Annick Bertrand, who's a biochemist, Solène Rocher, who's a molecular biologist, and Patrice Audy, who's a pathologist. And we have also a great team of research assistants who are doing all the work. So I'm also a dairy farmer. So we've been lucky, my husband and I, to be selected for the Dairy Farm Startup Assistance Program from the Fédération of Producteurs de lait du Québec. So since 2008, we have a Jersey herd. And since 2019, we decided to transform our milk. So now we have a dairy processing plant that we transform our milk in dairy product and also 7 kinds of cheese that we distribute across Quebec. So my breeding program is mainly focused on dairy production, but I also work with the beef and the hay industries. And I work primarily with alfalfa and timothy, trying to improve their yield, their nutritive value, and also their persistence to support the animal superior performance. And I also try to find new markets for forages. So we're trying, I work with switchgrass and reed canal grass, trying to improve their biomass yield and their quality for the bioproduct industry. So trying to find new markets in bioplastic or biomolecule also.
That is really interesting. Talk about being able to see the effects of research all the way down to the farm. Wow. Can you talk a little bit more about the overview and the importance of forage research and how producers benefit? And obviously, you're getting to see that firsthand.
I think there's 3 ways that forage research is helping for dairy producers. First of all, is by increasing on-farm profitability, in part by increasing the annual yield of high-quality forages. So research has been demonstrating that by increasing the energy content or the digestibility of forages, you increase the intake, animal intake, and the microbial protein synthesis, which will help increase the yield, milk yield production, the protein content of this milk, and also reduce the losses and nitrogen losses to the environment. That's the first way that forage research can help. Another way that forage research can help dairy producers is by mitigating climatic change, which will affect forage production. So a change in climate will bring or accentuate biotic and abiotic threats to the forage production. So in Eastern Canada in the past 3 years, we've been seeing a lot of increase of summer droughts, insect damages. In spring, we saw flooding of alfalfa fields. We also saw more root rot damage, and we've seen also more winter kill due to episodes of higher temperature during the winter or even rain, which will reduce the snow cover and will allow the freezing temperature to reach the alfalfa and killing it. So that's another way that research can help. And the third way, I think, for me, would be to quantify and evaluate the economic importance of ecosystemic services, which are provided by forages, which will help the producer make farm decisions, but also all Canadians to be more aware of the importance of forages in our system.
Oh, thank you. And just, it helps always to provide different insights onto the importance of this research. And sometimes there's an area that we wouldn't think of by ourselves. So thank you for that. What are the objectives of the current work that you're doing with alfalfa?
The alfalfa breeding program is focused on the 3 pillars of alfalfa production. which is increased persistence, increased yield, and increased forage quality. So for the increased persistence, we're looking a lot at the cold tolerance and the disease resistance. For the increased annual yield, we're looking at the fall dormancy, while we're looking for non-structural carbohydrates content and cell wall degradability for improving the quality of alfalfa.
Do you have any results to share from recent work?
Yes, we have a lot of research results that we could share. First of all, for persistence, so improving cold tolerance. So we've been working with alfalfa and red clover. So we were able to increase of 5 degrees the cold tolerance of both species with an indoor freezing stress selection protocol that we've developed in Quebec. So here you can see in alfalfa, we've been through going from -16 to -24. And in clover, we've been going from -10 to -14. So that's incredible for the persistence of our legumes. So here in the slides, you can see the field trials that we've been to evaluate the increase in cold tolerance of these species. Here you can see a field trial on alfalfa. So you can see 2 cultivars. You have evolution, which hasn't been selected, and the one which has been 2 cycles of selection. You can see the improvement in winter survival. We've been also working with DRECA and other cultivars. So we've made huge progress in cold tolerance for legumes. We also have been working in improving root rot diseases in alfalfa, since we have more flooding in the spring. So we've been developing an indoor also protocol to accelerate the selection for Phytophthora and Aphanomyces resistance. And what we're also doing is trying to do recurrent selection to increase the allele, the genes which are coding for these traits. And we're trying to find molecular markers linked with those genes so we could accelerate even more the selection process. So here you can see in the lab and also in the field the progress that we made for survival of these cultivars with the disease resistance. For the nutritive value, we've been working a lot with increasing energy content, and the dairy farmers of Canada have been financing part of this research. So part of you is in there. So here you have the increased energy content in the one cultivar that we've been working with. And with 1 cycle of selection, we were able to increase by 5% the energy content of this cultivar, which is without even affecting the yield. So after only 1 cycle of selection, we're working at the 4th cycle of selection with the dairy cluster project. For the nutritive value, we're also working on increasing cell wall degradability. So we've made huge improvement in the lab for a selection protocol that we've been through 2 cycles of selection, and we were able to increase by 15% the degradability of the cell wall without affecting even the yield or the sugar content of the plant. So those are lab research and results that we have already. And now we're at the stage of doing the broad selection to make a cultivar. So for the yield, we're trying to reduce fall dormancy. So what we're really doing is trying to combine the cold tolerance protocol that we have and developing a new protocol indoor also for fall dormancy. So we could increase the length of the season to have a higher yield in the fall. So without reducing the winter survival of our plants. So here you have 1 cultivar, which is peas, which is cultivated in Western Canada in Peace region. And you can see with 1 cycle of selection, we were able with our indoor selection to select the ones which are less dormant, which are taller. And you can see in the field, this is a field in Alberta. So you can see that the peas, the original population, and the ones selected with only one cycle of selection, the height of the plant in the fall is higher, and the yield is higher also. And now we're trying to combine the fall dormancy reduction and the freezing tolerance in the same breeding technique to improve both at the same time, because both traits are highly correlated, but they're not genetically linked. So we think that we're able to break this correlation. So that's our hypothesis.
So how long would it take you to get from the research stage to commercialization? What's the time length in there?
It's really a long time.
So yeah, for producers that are getting excited right now, what's their manage their expectations and anticipation?
Okay, so what you have to know is that the breeding program is always on the go. So there's never a starting point. Well, a project can start, but you can be producing cultivar at the same time you're developing other things. So it's always on the go. So first of all, you do the research. Research can take about 5 to 10 years to develop a new breeding program, a new breeding approach. So a new idea and a new trait that you want to work with. It takes you about 5 to 10 years just to find the way to improve it. So after that, you have to do a field trial, which takes about 3 years to determine if the trait that you've been working on has been improved, and also to look at the other agronomic quality of the plant. If you're altering, for example, by selecting this trait, you're altering its productivity or its winter survival, you don't want that. So you need to look at the others' agronomic trait. So this is the research part of so it takes about from 7 to 10 years to develop something, a new concept. After that, you have the population development. So once you have your methodology, you're using it to produce a population. So you do a cycle of selection. It takes you about 2 to 5 years, depending on the trait. For cold tolerance, we are now at the 6th cycle of selection, and it took us about 5 years. So it depends on the trait also. After that, once you have your interesting genotypes, the one that you've been selected, you cross them together and you do a progeny evaluation in the field. And now you're trying to look if the trait has been transmitted to the descendant. You try to see if the descendant, the progeny are vigorous, have a quality for agronomic traits, for other agronomic traits. After that, you go back to the genotypes and you select the ones which have the better performing progenies. And these genotypes, you cross them together. So maybe you had 50 at the beginning and now you're about at 30 genotypes. You cross them and you produce the pre-breeder seeds. That's another year. And after that, you have the seed multiplication and evaluation trial. So once you have the breeder seed, you do a multi-location field evaluation, which takes you 3 to 5 years, depending on the climate. So you test it against the other cultivars, which are already on the market, and with the base population also, to see if the improvement that you were looking for is there. And after that, you produce the synthetic seed. You multiply it to do the seed, and the cultivar is now offered to the seed company. We do this each year, and the seed company are responsible to produce the seed increase, which are the pedigree seeds. So for the research, it takes you 5 to 10 years. And after that, for the breeding, the population development, and the seed multiplication, you're about at 15 years. Each year, you have population at each step. So you have population that are getting out and the population that or project that you're starting. So you have material in every aspect of the development of a cultivar.
So I'm just amazed at the length of time that it takes, and it shouldn't amaze me. I mean, nothing worth value ever comes easy, but how complex it is, and like going through the stages. So I think, yeah, you laid that out really well. And I said, I'm just excited to add that clarification. So in Alberta, part of the discussion with the research committee has been on finding forage research to invest in. And again, with the larger focus in Western Canada being on beef production and beef forage, many of the times that we see applications, there isn't a focus on nutritional quality. So really exciting to hear the work that you're doing and that there is a focus on nutritional quality, and we're getting it without losing yields, and then just setting it up to understand of, great, we've got this coming. When can I actually buy this seed and take off my first crop? So I'm hearing that because this work's underway, maybe it's not quite 15 years that a producer in Alberta would have to wait for this seed, but it's going to be a good many years that they are going to have to. But the really important thing here is, again, just the progress is happening. And so the question to you then is, are there potential economic gains for a producer in adopting new cultivars, and what would those be?
So studies have demonstrated that producers which are using new alfalfa cultivars, for example, which have 5% yield increase, could have an estimated 43% return on investment. So that's the best way to transfer science to the field. You cannot find another way that would give you an investment, a return on investment that much. So, and for dairy production more specifically, for example, for each 1% increase in forage digestibility, you would have a 0.17%, 17 kilo per day of dry matter intake increase, and a 0.25 kilo per day increase in milk production. So you do the math. It's very impressive how a small difference in the genetic of a cultivar could make a huge difference in the bull tank.
Certainly. And so I have a question that's a little off of script. I apologize for that. And tying into the economics, knowing that each producer will have their own way of looking at their economics and optimization of that. When you're doing the forage research, do the harvest methods and timing get looked at as well? So when a producer's taking off their crop, in what form, whether they're turning it into hay or silage?
When we're working with in genetic, do we look at the management also of the plant? Is that it?
And I'm thinking more so when you said it got into the field trial stage, then do they look at, would it be like treatments of harvest timing and harvest method?
Okay, no, when we do the field trials, we're trying to do the same management that we do every time, so we can replicate and we can compare cultivars. And but what we're trying to do is in each project that we do, like the dairy cluster project, I'm trying to look at a everybody who's involved are in the different research sphere.
So really looking like having like a research team with members from different specialties looking at the problem from different angles and trying to come up with different solutions. So whether it's, okay.
That's what we're trying to do. So for the dairy project, for example, the dairy cluster, we're looking at energy content in alfalfa through genetic, but we're also looking at the management. So what mixture of species could we use to increase the energy content of forage? what other trait could we use to increase the energy content? So we're looking at different way to increase the same, around the same problematic or the same trait that we're looking at. I don't know if that makes sense. My English, I know in my head.
No, and
I like really logic, but in
I threw that one at you off script for sure. And so I think that helps answer, question from producer perspective of the influence and impact of research. And then also I get this seed, I put it in, I go to harvest it. There is a lot of impact that a producer would still have on what they're taking off. So it's not a silver bullet, all the research.
No.
And so then it really comes down to, say, the experience of producers and them sharing that with their producer peers as to best harvest method and best timing for a new cultivar. Would that be fair?
Yes. What we're always trying to do is have new nurseries, alfalfa nurseries, for example. And during the 3 years in the nurseries in the field, I do fork cutting, so I stress the plant. I do low fertilization, and I do a mixture of grasses with my alfalfa, so they have competition. So I'm trying to grow it as it should be managed in the field, or extremely managed, intensive management. So if you have a great condition in your field, a soil which is really highly nutritious, but high fertilization or organic matter in your soil, and you're doing tree cutting, and that you're managing it to have a higher persistence of your plant in time, you will have a great yield, because I'm stressing it and I'm selecting the ones which are the most vigorous and the highest yielding and the higher winter survival of these plants at the beginning of my selection trials.
Okay, so thank you for explaining that. I think that really goes to show the different growing conditions then that you try to present during the field trials. You had highlighted focus on cultivars looking at, let's say, increased energy. Is there any focus among forage researchers on breeding forages to reduce greenhouse gas emissions?
So what we're trying to focus is more management than genetic. Genetic, Youssef Papadopoulos has developed a new cultivar of alfalfa, which has a higher a bigger root system. So probably it would sequester a higher amount of carbon in the soil. But usually what we're trying to do is through management, that we're trying to, for example, have a higher persistence of your alfalfa. So you have a higher period of time that your crop will sequester. You have higher sequestration of carbon in your soil. So it's more management and persistence of your field, of alfalfa field, that we're trying to do. But I don't know. Well, all my colleagues are not working on trying to improve alfalfa, for example, for carbon sequestration or reduce the emission. But we're trying also to see, we're more trying to look at the persistence, for example, of alfalfa. If the carbon content in the air, the CO2 concentration in the air is increasing, if the plants will be performing better or worse, are they having effect of these increase in carbon in the air? So those are the aspects that we're looking, but we're not really breeding to increase their capacity at this point.
So that highlights a bit of another focus from the group. Are there other forage research projects currently underway in your lab? Or what can we hope to learn from your group in the future?
This was alfalfa, the alfalfa breeding program. So we have also a program in Timothy that I'm working for the hay industry. In Eastern Canada, Timothy is widely used in a mixture with alfalfa. So that's why I'm working on it. It's winter survival is incredible, so we need it these days. And I'm working also on switchgrass. So we're working a lot on this grass to increase its yield and its disease resistance. So to improve its biomass production, so we could either use it as bedding in dairy production, or also we're trying to see if we could use it as a combustion material for pellet production. And we're also trying to see if we can use it also in bioplastics. So this is the other way that we are looking at it. In alfalfa, I've presented all the aspects that we're working presently in our labs. So we're working a lot in collaboration with the other breeders across Canada. So we're working with Joseph Papadopoulos in the Atlantic region on clover. So we're trying to increase clover survival. So we've been clover survival for winter survival. We're also working with Billy Jutu in Saskatchewan on grasses. So we're looking at different species and trying to see the energy content on the carbohydrate content in their root system to compare it with their winter survival. And we're also breeding for Timothy, for tall fescue, for orchard grass, and brown grass grasses together. And we're also working with Surya Sharia from Alberta, Lethbridge, and we've been working with him for salt tolerance in alfalfa. So we've been able to develop some cultivars that are more resistant to salinity. So it's about it too.
Well, that about it sounds fairly busy and very collaborative across Canada. So congratulations to you and your team on that. I know from the perspective of producers, when they're looking at research projects and funding them, I mean, collaboration's a big one, and I mean, you guys have got it from east to west. So wow. I guess to wrap up, is there anything else that you would like to share with producers, either about your research or about the development of new forages?
I wanted to point out that breeding is really a long process, and it takes a lot of investment. So dairy producers have been working with us for the five last years. So we're really grateful that you were investing in forage research and breeding research that we're doing. And we hope that we can continue a collaboration with you in the future, because we have a large team, and Agriculture Canada is putting a lot of money in forage breeding across Canada, and we need to get these cultivars out to the field. So these last year has been difficult for funding research, but we have a lot of population which have been developed, and now we're at the stage of seed multiplication and field trials, and we will need the support of the industry to bring these cultivars to the market.
No. Well, thank you so much for your time and sharing your knowledge. I think, again, just doing this now shows, I guess, to Alberta Milk and the producers that make Alberta Milk, the value of investing in research when they get to see firsthand, and I say firsthand, and advanced screening what's coming their way in a few years. So no, thank you very much for taking the time to share, because we know it takes you away from the work that you're focusing on to get those new forage varieties to producers.
Thank you.